Hello students, in the previous session we discussed about ellipse and some definitions related to it. In this session we shall solve some examples to understand the ellipse in a detailed manner. Here we will discuss type 3 examples here, which are based on finding the equations of an ellipse when some of its parts are given. Here is an example for us. Find the equation of the ellipse whose axes are along the coordinate axis, vertices are plus or minus 5, 0 and foci at plus or minus 4, 0. Look into the solution. Let the equation of the required ellipse be x square upon a square plus y square upon b square is equal to 1. Take this as equation number 1. The coordinates of its vertices and foci are plus or minus a, 0 and plus or minus ae, 0 respectively, but the coordinates of vertices and foci are given as plus or minus 5, 0 and plus or minus 4, 0. Therefore, a is equal to 5 and ae is equal to 4. So, e is equal to 4 upon 5. Now, b square is equal to a square into 1 minus e square. So, b square is equal to 25 into 1 minus 16 upon 25, which on simplification gives us 9. Substituting the values of a square and b square in equation 1, we obtain x square upon 25 plus y square upon 9 is equal to 1, which is the equation of the required ellipse. Here we have another example. Find the equation of the ellipse whose axes are along the coordinate axis, vertices are 0, plus or minus 10 and eccentricity E is equal to 4 upon 5. Look into the solution here. Let the equation of the required ellipse be x square upon a square plus y square upon b square is equal to 1. Take this as equation number 1. Since the vertices of the ellipse are on y axis, so the coordinates of vertices are 0, plus or minus 10. Therefore, b is equal to 10. Now, a square is equal to b square into 1 minus e square. Therefore, a square is equal to 100 into 1 minus 16 upon 25, which on solving gives us the value as 36. Substituting the values of a square and b square in equation 1, we obtain x square upon 36 plus y square upon 100 is equal to 1 as the equation of the required ellipse. Let us look up one more example here. Find the eccentricity, foci and the length of the latus rectum of the ellipse x square plus 4y square plus 8y minus 2x plus 1 is equal to 0. Look into the solution. The given equation of the ellipse is x square plus 4y square plus 8y minus 2x plus 1 is equal to 0, which can be simplified as x square minus 2x plus 4y plus 8y is equal to minus 1, which can be rewritten as x square minus 2x plus 1 plus 4 into y square plus 2y plus 1 is equal to minus 1 plus 1 plus 4. We have added 1 and 4 on both the sides in order to complete the square. That gives us x minus 1 whole square plus 4 into y plus 1 whole square is equal to 4. Now, on simplification, we get x minus 1 whole square upon 2 square plus y plus 1 whole square upon 1 square is equal to 1. Take this as equation number 1. Shifting the origin to 1, minus 1, without rotating the axis and denoting the new coordinates with respect to these axes by x and y, we obtain x is equal to x plus 1 and y is equal to y minus 1. Using these relations, equation 1 reduces to x square upon 2 square plus y square upon 1 square is equal to 1. This is of the form x square upon a square plus y square upon b square is equal to 1, where a is greater than b. On comparing, we get x square is equal to 2 square and b square is equal to 1, which gives us a is equal to 2 and b is equal to 1. Let E be the eccentricity of the ellipse, then b square is equal to a square into 1 minus e square, that is 1 square is equal to 4 into 1 minus e square, which on solving gives us e is equal to root 3 upon 2. The coordinates of foci with respect to the new axis are x is equal to plus or minus a e and y is equal to 0, that is x is equal to plus or minus root 3 and y is equal to 0. So, coordinates of foci with respect to old axis are 1 plus or minus square root 3 comma minus 1. This we have obtained by putting x is equal to plus or minus root 3 and y is equal to 0 in equation number 2. Length of the lattice rectum therefore becomes 2b square upon a, that is 2 into 1 square upon 2, that gives us 1. We have one more interesting problem here. A man running a race course notes that the sum of the distances from the two flag posts from him is always 10 meters and the distance between flag posts is 8 meters. Find the equation of the path traced by the man. Look into the solution. Clearly, the path traced by the man is an ellipse having its foci at two flag posts. Let the equation of the ellipse be x square upon a square plus y square upon b square is equal to 1, where b square is equal to a square into 1 minus e square. It is given that the sum of the distances of the man from the two flag posts is 10 meters. This means that the sum of the focal distances of a point on the ellipse is 10 meters. Therefore, 2a is equal to 10 and a is equal to 5. Since it is given that sum of the focal distances of a point is equal to 2a. It is also given that the distance between the flag post is 8 meters. Therefore, 2ae is equal to 8 and ae is equal to 4, since distance between two foci is 2ae. Now, b square is equal to a square into 1 minus e square. On solving, b square is equal to a square into 1 minus a square e square, that is 25 minus 16 is equal to 9. Hence, the equation of the path is x square upon 25 plus y square upon 9 is equal to 1. Now, students, let us summarize the concepts we have studied in this chapter. An ellipse is the locus of a point in a plane which moves in such a way that the ratio of its distance from a fixed point called focus in the same plane to its distance from a fixed straight line called directrix is always constant, which is always less than unity. The constant ratio of generally denoted by E and is known as the eccentricity of the ellipse. If S is the focus, Z Z dash is the directrix and P is any point on the ellipse such that M is the foot of the perpendicular from P on Z Z dash, then SP is equal to E into PM. The equation a x square plus 2h x y plus b y square plus 2 g x plus 2 f y plus c is equal to 0 represents an ellipse if our determinant is equal to a b c plus 2 f g h minus a f square minus b g square minus c h square is not equal to 0 and h square is less than a b. The equation of the ellipse whose axes are parallel to the coordinate axis and whose center is at the origin is x square upon a square plus y square upon b square is equal to 1 with the following properties. We have here the equation of ellipse as x square upon a square plus y square upon b square is equal to 1, where a is greater than b. Here the coordinate of the center will be 0, 0. In the second case, where we have equation of ellipse as x square upon a square plus y square upon b square is equal to 1, where a is less than b, the coordinates of the center will be 0, 0. Now, look into the coordinates of the vertices. For the equation x square upon a square plus y square upon b square is equal to 1, where we have a to be greater than b, the coordinates of vertices will be a, 0 and minus a, 0. And in the other case, where we have a to be less than b, the coordinates of the vertices will become 0, b and 0, minus b. Now, look into the coordinates of foci. For the first case, where we have a to be greater than b, they are a e, 0 and minus a e, 0. For the second case, x square upon a square plus y square upon b square is equal to 1, where a is less than b, the coordinates of foci will be 0, b e and 0, minus b e. The length of the major axis in the first case, where a is greater than b, will be 2a, and in the second case the length of the major axis where a is less than b will be equal to 2b. The length of the minor axis will be 2b in the first case where a is greater than b, and it will be equal to 2a in the second case where we have a to be less than b. The equation of the major axis will be y is equal to 0 for the ellipse where a is greater than b, and equation of the major axis for the second case where a is less than b will be x is equal to 0. In a similar way, equation of the minor axis for the equation x square upon a square plus y square upon b square is equal to 1, where we have a to be greater than b, the value of x will be 0. And in the second case where we have a to be less than b, the equation of minor axis will become y is equal to 0. Now, equation of the directrices where we have a to be greater than b, we have x is equal to a upon e and x is equal to minus a upon e. In the second case where we have a to be less than b, the value of y will be b upon e and y is equal to minus b upon e. Look into the eccentricity. In the first case, we have where a is greater than b, it is e is equal to square root of 1 minus b square upon a square, and eccentricity for the second case where a is less than b, we have e to be equal to square root of 1 minus a square upon b square. Now, length of the lattice rectum. For the first case where we have a to be greater than b, the length of lattice rectum will be 2b square upon a, and the length of the lattice rectum in the second case where we have a to be less than b, it is 2a square upon b. Now, focal distances of a point x y. For the first case where we have a to be greater than b, it is a is equal to plus or minus E x, and in the second case where we have a to be less than b, the focal distance of a point x y will become b is equal to plus or minus E y. So, students, hope you enjoyed studying the concept of ellipse under conic sections. Thank you.